Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. We are on a special series and we are looking at how to work on MicroPython using Raspberry Pi Pico. Alright guys, so let's take a look. We are on lesson number 12 and we are going to get into more deep dive connecting into multiple sensors. Alright, so in this particular lesson I am going to show you how to connect ultrasonic sensor. It's a very popular sensor in the world. This sensor is so much compatible. This is absolutely flawless. This sensor works almost with every microcontroller in the world. Alright guys, most of you would have seen this and worked on this, but using Raspberry Pi Pico, it's pretty little tricky and it's funny and it's very interesting and powerful as well. All right, so let's take a look. So in this particular lesson, I will show you how to plug into your microcontroller with ultrasonic sensor. You may use HCSR04 or any other model. Everything is going to be almost same. The drawing is going to be same, right? So basically, the ultrasonic sensor to your Pico, we will also write once you get connected based on this circuit what you are seeing just behind me, we will also write multiple lines of MicroPython code, and basically that's going to start reading the values received from the ultrasonic sensor. And going forward in the future lesson, I will also show you how to read the value and make things work at the background by connecting into different devices. So that's where this lesson is leading into. There are actually many ways to detect the movement and distances with your electronics, either using Arduino or whether you use Pico or any other microcontroller. But however, ultrasonic sensors on the other hand uses pulses of sound, okay, and a simple calculation to determine the distance between themselves, the physical distance where it is sitting, and the objects in front of them. All right, that's the way it works. They are also often used, not often, actually most of the time it's used in robots, mainly on robots, robotic applications, okay. Just so basically to make sure that the robot doesn't walk or cross over any of the obstacles or fall below any the ground point or bang into the objects. So in this tutorial, in this particular lesson, I will show you how to use the ultrasonic distance sensor using HCSR04 so that you can quickly determine the distance of an object from your Pico, from where you are plugging it in on your breadboard, and the distance between that and any other object in between. We are going to read that value. So what you need to do, guys, first you need to obviously you need to plug in all this circuit as shown here. You just follow the pin architecture which I showed you in a couple of lessons before. If you still have any doubt, this is the architecture drawing of Raspberry Pi Pico. You can follow all the green pins, okay, the green, what is written in green. Do not get confused, once again, do not get confused with the physical pin of 1 2 3 4 5. You need to follow the GPIO pins, GP pins, which is written here. GP0, GP1 is physical pin 2, GP3 is physical pin 5, GP4 is physical pin 6, GP5 is physical pin 7. So like that, similar way till pin number 40. That's the way it works, because these are the green pins what is mentioned here, like 10 11 12 13 14 15. These are the pins will be used in the MicroPython code. That is the pin you will send the signal and trigger the controllers. All right, so go ahead and plug this pin, guys. So basically it's you are inserting the HCSR04 ultrasonic sensor into the breadboard, all the four pins in the four columns, and then you have to connect the 3.3 volt pin of Pico to the VCC pin of the ultrasonic sensor using a male to male jumper wire. Okay, that's how you build the breadboard circuits. And then you connect the ground pin of the Pico to the ground pin of the ultrasonic sensor using the jumper wire again, and then connect the trigger pin of the ultrasonic sensor to the GPIO pin 3 of the Raspberry Pi Pico. Okay, and then you connect the echo pin from the ultrasonic sensor to the GPIO pin number 2 of Pico. So once you are ready guys, then we will get into the coding aspects. I keep the circuit ready and then I'll show you what to code, how to code, and we will take it forward from there. Alright, so let me connect my Raspberry Pi Pico and then I will open up the Thani IDE. There you go, I can hear the sound. I am connected. Let me just open up Thani IDE. It's happy little IDE which is open now, just right behind me. I hope you guys can see the IDE. Now let's write some code to make sure that we are able to detect the sensor reading. Alright, so with this particular circuit built, what we need to obviously do, the first step, and you had seen this in all the previous lessons, we need to import the pin class from the machine library. Alright, remember the machine library, all the previous exercise, from machine import pin, right? That is what we are going to do. So the machine library, and then import the utime library. Utime is another inbuilt library for machine library. The machine library is basically used to control the GPIO pins, and the utime library for the time based functions. Alright, that's how we are going to do. Let's say from machine import pin P should be in uppercase, the pin, and then import utime like this. Import utime. Once you are done, now what we need to do, we need to create two objects, okay, trigger and echo, because ultrasonic sensor has got trigger and echo. These objects basically configures your Pico's GPIO pins where you are connected as per the circuit of the Pico to be used with the ultrasonic sensor. So you need to create an object. If there are more pins in a different kind of sensors you are using, you need to, for each pin you need to create an object. For now in this case, for example, our trigger pin is used to send the pulse of the current. We are sending a pulse of 3.3 volt. As such, it is an output pin basically, right? And the echo pin receives the reflected pulse to the echo pin as an input. So that's what we are going to do in this MicroPython. How do we do? Trigger equals pin. The P should be always in uppercase. Pin number as per the circuit, it is 3. And then pin dot out. Out should be all in uppercase. And then close the parenthesis. And echo, uppercase, lowercase, echo equal to pin number we are connected to. Which pin number was that? Okay, it's pin number 2. Pin number 2, and then pin dot in. We are reading the input like this, input of the distance signal. And then now what we need to do, we need to create a function. It's called ultra function. You can name the function. The best part of Python is you can create your own function. That is the beauty of MicroPython or Python programming, right? So you need to create a function called ultra. In this case I am creating as ultra because we are using ultrasonic sensor. Okay, ultra, but the function name always should end with 2 parentheses both the sides, okay, which will basically contain the code necessary to take the input reading. So let's say define a class called ultra. It should be in lowercase. Define ultra like this, okay, and end with a colon like this. And then as soon as you hit enter, the indentation should be perfect below the ultra. Let's say now what we need to do, we need to pull the trigger pin to low to ensure that it is not active, and then the pulse for 2 seconds. Basically we'll just give a gap of about 2 seconds. So basically the trigger pin we are setting at to low, and accordingly we need to write the code. So trigger dot low, okay, trigger dot low like this, and then close the parenthesis, and then utime, which we imported earlier, dot sleep underscore us to 2 milliseconds like this. All right, 2 seconds, sorry. And then now what we need to do, we need to pull the trigger pin high after 5 microseconds before pulling the trigger pin to low. Okay, that's what we need to do. That's the way the logically the program should work, and that's the way the signal detection from the ultrasonic input to output should work. This will basically send a short pulse from the ultrasonic sensor and then turn off the pulse. That's how it will ideally work. So let's say trigger dot high, close the parenthesis, and then u time dot sleep underscore us to 5. Initially we set it as 2, now we'll set it as 5, and then trigger dot low, and do nothing within that low. All right, now what we need to do, we had defined our functions. Now what we need to do is basically we need to create a while loop to check the echo pin. So for example, if no echo pulse is received, then the updated variable, the signal off, so that it contains a timestamp in microseconds. So that's the way it should work. So for example, while we need to come back to the main code, the main line of the code, while echo dot value, and that will be another, let me just scroll it up, while echo dot value equals 0 colon, let me scroll it up, equals 0, and then hit enter. We will come below the while loop, signal off. Okay, signal off equal to u time dot ticks underscore how many ticks per second, us ultrasonic. Okay, close the parenthesis. Now what we need to do, we need to create another while loop. We will just go back to the previous line. We need to create another while loop, this time to check if an echo has been received or not. This will basically store the current timestamp in microseconds to the signal on variable. That is the variable which we created, right? So how do we do that? While echo dot value, let me close the parenthesis, equal to on. Previously it was echo dot value equals to 0, that is off. Now we will on. If it is on, then what we need to do, signal on equals to u time dot ticks underscore us, like this. Signal on equal to u time dot ticks underscore us. Alright, now what we'll do, we had already created both input and the output from the ultrasonic. Now we need to create a new variable called time passed, kind of time pass, I'm just saying, which will basically store the value of total time taken for the pulse to leave the sensor, coming out of the sensor, and then hit an object, any object in between, and return back to the sensor as an echo pin. That is from the trigger pin to the echo pin, how much time it takes. That's what we are going to do. How do we do that? While time passed equals to signal on and minus signal on minus signal off. It's a simple calculation, right? Signal off. Alright, now what we need to do, once this is done, we need to create another new variable called distance. Okay, so what's going to happen is this particular variable will store the answer of the equation what we defined just now. So we will multiply the journey time, the time it takes, that is the time passed, by the speed of sound. That is, the basic formula is 343.2 microseconds, which is basically 0.0, I think it's 343 centimeter per second. I think I need to refer to this calculation because even I am not sure. I do a lot of R&D and try to fix it off. However, the product of that particular equation is divided by 2. Okay, divided by 2, as we do not need the total journey distance. So how do we do that? So we need to basically, within the while, say distance equals to distance. I hope I am correct. Let's see. I hope it runs. Time passed multiplied by 0.0343, and then we need to divide this by 2. You will understand why we are dividing this by 2. Alright, divide this by 2, and then what we need to do, once we receive the time the time distance, we need to print it out. We need to print out, okay, what it says, right? So we need to basically print a message to the Python shell that is at the bottom of Thani here, right, on the terminal, showing that, hey, I am able to detect the distance between a hit object in between, and this is the distance. So what is the distance? The program, the MicroPython, has to calculate and tell us what is the distance. So let's come out of, say, print. Let's say print. What do we print? The syntax. Let's say, for example, okay, it has to be a string. The distance from object is, and we will close this, comma, distance comma in centimeter. We will take it as centimeter in a double quote, like this. Now moving out of the function, we need to come out of this particular function. We have to now create another loop which will basically run the function every second. It's very important, right? So that is the logic. We'll come out of the loop and we'll create another loop. While true, okay, while true, we can actually, it's not mandatory that we need to use the while loop. We can also use a do while loop as well, which I'm going to show you at a later stage. While true, say my while true, ultra u time dot sleep is on. So what is on? That is 1. Okay, if it is 1, then what happens? Let's see. That should actually print the output. Now let's try and run this code. I hope it works. Let's hope for the best. All right, let's go through this again from machine. Import pin. All right, import u time, then the trigger pin 3, pin out, and then the echo pin is pin 2, pin input, and then we are defining a class for ultra. All right, this looks pretty reasonable. I hope it works. Let's see. All right, let's run this code, guys. I'm going to click the green button and I'm going to save it in Raspberry Pi Pico. All right, now why is it not running? I'm not seeing any error, neither. Let me run this again. This is kind of weird. I don't see anything happening. It is definitely saved. Run the current script. I am running this. Okay, Raspberry Pi Pico with RP2040. There is no error, neither the program is running. It's kind of weird. Alright, let's debug, guys. Let's find out what the issue can be. Let me possibly it should be, if there is a code issue, it should show the error, but unfortunately there is no error message in the terminal. That is kind of weird, right? So maybe I need to close the Thorny and open it again. All right, there you go, guys. So looks like there was an issue with basically saving the file. So if you can see at the bottom on the terminal, we are able to detect the distance, so which is pretty good. All right, so let's take a look at it. This. So if you see, let me just change the direction of my. Let me place my hand before. There you go, 1.976, and I'm just moving a little far away. If you can, let me just expand it. Can you see that, guys? There you go. So we are able to detect the distance, we are able to send the trigger, we are able to receive from the echo, and there you go. Yeah, it works perfect, guys. I don't see any issues in the code. Fantastic. All right. So I hope you guys enjoyed this lesson. In the next lesson or in the upcoming lesson, we are going to connect more number of sensors, and we are going to probably, by end of this particular series, we will be building a small robot, and at the same time we will also build couple of IoT applications. That we'll be connecting to multiple sensor to Pico and detect different variable environment around your house, or in an open environment, or agriculture or water or rain. All those detections can be done, and then we will send those signal into a browser, and then we will also control a bot where it can go move around automatically based on the temperature variables. A lot of things can be done, and I have plans for those. All right, guys, if you have any questions, if you have any doubts, do reach me out on the Zoom. I'll set up a Zoom call, I'll explain you, I'll take a one-on-one session with you to train you guys how best possible. Bye bye.